Good afternoon. Good afternoon. Hope all is well. Hope everyone's doing all right. Hope you guys had a great weekend. All right. Looks like everybody's in. Nope. Got a couple that's still trying to connect. All right. So while we're waiting on them, if I'm not mistaken, hold on. Trying to make sure I have it right. So we only did 4 point. Didn't we end in 4.1? Okay, thank you. Thank you. I got you guys confused with my other class. Yeah, okay. So we're doing 4.2, 4.3 today. Um, Sorry about not getting that video to you guys, video lectures last week. I'll post them today. Ended up having a loss in the family on Friday, so it kind of threw me off a little bit, but I'll get those to you today. Get you to you today. So any general questions or concerns before we go ahead and get into 4.2? All
Yes,
right.
I wanted to talk to you, Professor. I've been having a problem logging into Pearson for some reason. I had to call them today, but they was, I couldn't call over the weekend, but so we're still trying to figure out what's the issue.
Okay. So stay on afterwards so I can see if it's something that I can do to help you out.
Okay, thank you.
Okay. All right, cool.
Professor, I had a question.
Yep.
Okay, so just to be sure, um, our test, our first test for chapter one,
Hmm.
that's due by the 8th as well of August.
Yeah. Yep. Like I said though, you don't want to wait until August to start getting this stuff done. So most definitely you want to get it done way before then. But yeah, you have the luxury of the 8th to get everything in. Hmm.
Okay, most likely I'm going to I'll do it when I get home from work tomorrow.
Hmm.
So
Yeah, that's not a problem. Yep, you're good to go. All right. Anything else? Anybody else before we get rolling? All right, so let's look at 4.2 least squares regression or least squares regression line. It's a line that minimizes the sum of the squared errors or residuals. Going to come back to that um, in one of the examples, looking at the residuals. Or in other words, though, it's the line that best explains the relationship of the data. So it's the line that best sums up the relationship of the data. So, when it comes to our scatter plot that we introduced last section, whatever line can best sum up that data, the pattern of that data would be your least squares regression line. One second, I want to see something. Okay, yeah, that's what I need to see. All right, anybody still copying that before I scroll up? I'm gonna make sure we're good.
So that red line in the scatter plot is an example of a regression line.
Right. So our scatter plot normally is just the dots, and so I was just showing you that line that's created by this equation that we're about to get into would actually be a representation of your least squares regression line. Yep. All right. So if we want to find a regression line, it's given by what's right here in black. Y hat equal to B1 or B sub 1 X plus B0. So, like I said, this is considered Y hat, and it's also considered your predicted Y. And you'll see in a few minutes, what we mean by that. But we're going to use this regression line to predict possible outcomes depending on what an observation could be. And so that's what this is for. So in other words, let's say if you, and it's based on your previous example. So you use your previous observations. So you have observations. From that observation, you'll create this equation. And so let's say it's based on sales. You'll be able to plug in the value for X. Say if you sell this amount, this is how much you expect to make. You know what I mean? So you plug in the value for x, this is what the outcome would, be. And that's based on your previous observations. So right here, B1 or B sub 1, the way you would calculate that is by taking R, which is your correlation coefficient, multiplying it times S sub Y with S sub X, which is the standard deviation of your X values and standard deviation of your Y values. And then B0 or B sub 0 or B naught, depends on what different books have, used as the terminology. It's going to be Y bar minus B1 times X bar. So notice B1 is considered your slope. B naught or B0 is considered your y-intercept. And right here, what I was saying, R, X bar, S sub X, Y bar, and S sub Y equal to. Don't forget your X values. I think I look green. Your X values are your explanatory variable. And your Y values, response variables. So just reminding you of that. And in the purple, that's what I mentioned. Your regression line is used to predict an outcome based on previous observations. All right. So first way we're going to find a regression line is to use these formulas right here. The book is going to give you two different ways that you would be asked to find a regression line. Once again, either you'll have the information to use these formulas, or they'll give you just a data set wherein, like I mentioned last class, when you go to easycalculation.com and just type in your data values and hit enter. So that, we've already talked about how to do that. You just type in data values and enter. Next, what we're about to do is actually try these formulas out and make sure we're okay with the information that they give you. All right, everybody okay? Scroll up. All right, so find a regression line. They give us R, X bar, S sub X, Y bar, and S sub Y. So the first thing that we have to find is B1. Have to do that first because notice in B0, B1 is included. So you have to find B1 first. So we have R is negative 0.946, X bar is 4, S sub X 2.44949, Y bar is 10, S sub Y 5.612486. So we find the B1 first, and that's R times S sub Y over S sub X. And that's this substitution right here. And when you do the math, you get negative 2.1676. So, of course, make sure you have a calculator that can, that's dependable. Don't want to have to do this by hand. All right. Any questions on B1? All right. B0 is Y bar minus B1 times X bar. So once again, B1 is right here, and then we take in Y bar and X bar from the given information. And that's this substitution right here. All right, got 18.6704. Any problems? All right, is everybody good? And so use a regression formula. This is the formula right here. Y hat is equal to B1x plus B naught, or B0. And that's what we did here, just plug it in. And so my math lab will probably have books, I mean not books, boxes, you know, like this. And then you type in the numbers in the box and just make sure the one that's supposed to be in front of X, you know, you type that in the one that's in front of X. Also, just pointing out that you could reverse the order and such that now this is still connected to X, but you know, I had that second, it had the 18.670 for first. So just make sure that you're paying attention. Notice that 2.1676 is still negative, no matter which one you use. And the 18.6704 is still positive. You know, like I said, this one is still attached to X. It's just that, like I said, one is in the front, the other one's in the back. So he's still holding the same characteristics. All right. Any questions on what we did there? All right. Any problems with the process? Now, there may be an app or something like a website that can use your data given to you in this form and just find the regression line. You know, feel free to look for it. But, you know, if not, then you can just use these formulas. Also, make sure you pay attention to when you plug in these values right here into these boxes, how many decimal places my math lab want, because if they want 4 and you type 5 or you only use 3, then they could mark it wrong. More than likely, they will mark it wrong if it says round to 4 decimal places or round to 3 decimal places. So make sure you're paying attention to how many decimal places they are requiring of you when you go to put those numbers in those boxes. All right. Problems with the process? Are we good? All right. So let's look at another one. Yep. So find the regression line, and they're going to give us a data set. So we'll go to, like I said, easycalculation.com, go plug that in and see how they work for us. So they're telling us first, find a regression line, predict the distance the ball will travel when hit with a club head speed of 103 miles per hour. Then C, determine the residual for the predicted value from the result. And C, is the distance in the table above or below average among balls hit at 103 miles per hour. All right, give you guys a chance to write that down before we go to the data set. All right. I'm still holding on to B. All right, so we're going back to our club head speed and the distance. In 4.1, we talked about this set of data before or already. So if you copied it then, don't want to copy it the second time, then that's fine as well. Just taking a picture so I can go to easycalculation.com. But yeah, it's the same data set. And the club head speed is our X, or in other words, our explanatory variable. Distance is our Y, which is our response variable. We talked about that before as well. Anybody still copying before I go to the internet? All right. All right, so just like before, I would do a regression line. I'll put first what I'm trying to find, and then I would do easy calculation. And notice once again, it's the first one. And type in your values. We have 8 observations. Once again, go back and check your data values before you consider your answer legit, because remember, messing up one data value, even by one digit, will change your outcome. So you want to make sure you are accurate in your submissions. All right. So there we go. It gives you, remember what's sitting in front of X is your slope. The other numbers, your y-intercept. And then it gives it to you as the whole equation. So before we go back to the notes, any questions on that? So once again, they can give you data one or two ways. Either they can give you the pieces and you have to use the formulas. Remember that was the first example. Or they can give you a data set like this and then type the data values into app, website, calculator, or something of that nature, and then get your equation. All right, any problems? Any problems before we go back to the notes? All right. So that's what we have right here for A. Once again, just emphasizing you can write it either way. All right, so just realize you can write it either way. 3.166x minus 55.797 or negative 55.797 plus 3.166x. So now B asks us to predict the distance the ball will travel when hit with a club head speed of 103 miles per hour. So that means you're going to take 103, plug it in for X, and figure out what your outcome would be. So this 270.3 yards is your predicted outcome if you were to swing your golf club at 103 miles per hour. All right. Any problems with B?
And I'm sorry, that's from plugging in the numbers into the calculator.
When you
From
say that, which one are you talking about?
how you get your. I'm sorry, I kind of lost track for a second when you got the way how you're supposed to get it. The
All right,
prediction.
you faded out for a second. So now you're talking about this right here, A?
B. I'm talking about B. I'm sorry.
Okay, right. Okay, so now the equation that we're using came from A, and it came from these data values when I plugged it into the website. So that's how I got, this formula. And then I'm taking this formula, using it here, but they gave us 103 in B. That's right here.
Oh, okay.
Yeah.
Gotcha.
All right. So did I answer all your questions? Just want to make sure we're good.
Yes, it did.
Okay, cool. All right. Any other questions on A or B before we go to C? All right. So C asks us, let's go here, determine the residual for the predicted value from the result in C. From the result in C, that should have been from the result in B, right? So determine the residual for the predicted value from the result in B. Right, that should have been B. Is the distance the ball traveling the table below average or above? Okay, so first thing we're looking at the residual. The way we calculate residual or error is by taking your observed Y minus the predicted Y. So in other words, that's Y minus Y hat. All right. So where will we get Y? You cannot get Y unless you have an actual observed or actual observation from 103. Somebody, the guy hitting it at 103 miles per hour. And we do have that. And that's right here. When he swung at 103 miles per hour, it went 274 yards. All right. So that's where we got 274. And that's why I wrote chart down here. And then from the equation, 270.3. Subtract those, we get 3.7 yards. All right, so the observation in the chart is above average balls hit at 103 miles per hour. And I got the purple going on there, letting you know the reason why it's above is because it is positive. So that ended up being negative 3.7 yards. Let's say, that's what, if the outcome was negative, then the observation in the chart would have been below average. All right. So once again, it's your observed Y minus your predicted Y. And if it's positive, that means it's above average balls hit at 103 miles per hour. But if it's negative, that means it would be below average balls hit at 103 miles per hour. All right. Questions? Any questions? All right. So everybody good. That's it for 4.3. Just the residual line, how you calculate it and what it means, how you would use it. All right. Can I scroll up? Very good. All right. Last thing out of chapter 4 is the coefficient of determination. So it measures the proportion of total variation in the response variable that is explained by the regression line. It basically tells how reliable the regression line is. It is the correlation coefficient squared. So remember lowercase r that we calculated in 4.1. When you square that, you have the coefficient of determination. Give you guys a chance to write that before we scroll up. All right. It's denoted by capital R squared. And it's between 0 and 1 inclusive. So if R squared, a coefficient of determination squared, if it's equal to 0, the regression line has no explanatory variable value. So that means your regression line is pretty much useless. It won't give you any type of prediction that will be reliable. But if R squared is equal to 1, your coefficient of determination, if it's equal to 1, then your regression line explains 100% of the variation in the response variable. So that means that it's going to be 100% accurate. So of course, being 0 or being 100%, are the extremes. But that's what 0 means versus 100% mean. So somebody said go up a little bit for a second. For the person that need me to go up, did I go up further enough, far enough? Is that good? No. No. Okay, not a problem. All right. Is everybody good? I don't know how far we are. All right. So next thing, I believe it's the last thing, if I'm not mistaken, that we're going to do here is determine and interpret the coefficient of determination for the club head speed versus the distance. All right. So first, find the correlation coefficient. Now we've already done that for this set of data, so didn't revisit the process. Remember, all we did was we had our data set, club head speed, and the distance. We put that in easycalculation.com, and we got this value right here. R is equal to 0.939. So that's the first thing you want to do is find correlation coefficient. All right. Second, you're going to square that correlation coefficient. You want to find the coefficient of determination. You're going to square R. And that gives us 0.882, which is 88.2%. All you do is move your decimal 2 places to the right. All right, so everybody good. So that's all the calculation calls for. Now it's all about interpreting the numbers that you have. So this means that 88.2% of the variation in distance is explained by the regression line, or predicted by the regression line. Then 11.8% of the variation is explained by other factors. So in other words, 88.2% of the time, the regression line is going to be reliable, is going to predict accurately. That 11.8%, and we get that from subtracting 88.2 from 100. So that 11.8%, other factors would come into play that prevent it from being accurate. So in other words, let's say wind, could have blew the ball, strong enough wind gusts. Maybe the guy or lady, whoever's doing it, could have swung a little differently, twisted the hip a little differently. Different things that could prevent the regression line from being as accurate as possible is explained. Is at 11.8%. And so that means the regression line has 88.2% reliability. All right, questions? Any questions? Everybody good before we go to the next thing? Make sure we're all right. All right, let's move on to this page. No, you guys aren't doing the assignment. All right, so what we're gonna do here, like I said, you guys aren't doing the assignment, so don't worry about that. Looking at my math lab and where we are as a class, not individuals, I'm going to allow test 2 to be in my math, be unproctored as well. So that means test 3, chapter 5, chapter 6 tests will be our first proctored test. So I'm giving you guys a chance. Get in there. Let's go ahead and get in there and knock it out. Knock out these 2 tests. So your third test will be proctored. So we're talking about chapter 5, chapter 6 tests. So what you have that you have to knock out right now in my math lab. Well, let me do it like this. We talk about homework. Chapter 1, 2, 3, and 4. Don't forget definitions if you haven't gotten those to me from chapter 1 and 2. And then you have 2 tests. Test 1 and test 2. I don't think I posted test 2 yet. It's just me, coming up with this right now. Trying to reset. So that's what you guys, are held responsible for up to this point. I don't hold you responsible for anything that we haven't covered or anything like that. So up to this point, what you guys are held responsible for, like I said, is your homeworks from chapters 1, 2, 3, and 4, definitions from chapters 1 and 2, and most of you have turned those in, but if you haven't, make sure you get those into me as soon as possible. And then test 1 and test 2. Test 1 is on chapters 1 and 2. Test 2 will be on 3 and 4. So let's just in the chat.
In my math lab, there is a review. When is test 2 going to be up?
I'll post it as soon as you guys, log
Okay.
off. Yeah. And that test review, I'm glad she mentioned that. That's not mandatory. You guys don't have to do it. Don't forget, sent you guys that My Math Lab specifics doc, wherein I'll let you know about that. But I can use it for extra credit. So, but it's not mandatory once again. But I always suggest that you at least go in there, take a look at it, so you'll know what will be on the test. Somebody, let me get to the chat. So, no, you're not supposed to do any of the assignments. Yeah, the assignments, that's for when I have a 16-week grading, a 16-week class. I have a lot of room, you know what I mean, to be able to say, okay, this week, not this week, but this class, I just want you guys to go and not try to knock out this assignment, come back next class, just different things I can play with. But when we got 10 weeks, I'm not gonna throw extra stuff at you guys. We more so have to focus on make sure we get through content, give you guys an opportunity to digest the content that you get hit with stuff. So. Nope, you'll be fine. Don't do the assignments. The due date for test 1, due date for test 2, everything that's in my math lab that's unproctored, the due date will always be August 8th. But once again, the warning to that is that you don't want to wait till August 7th to try to do this stuff. You're supposed to progressively be doing your work as we progress throughout the course. Now, what that does do is that leaves room for life to happen, in which if you get behind, you don't have to ask me for an extension. You just need to get caught up. And so that's why that flexibility is there. But it's on you to not procrastinate and go ahead and get in there. So yeah, it's open. It's open for you guys to get in there and knock it out. Once again, the marker is me. We just knocked out chapter 4. You don't want to still be in chapter 1. You know what I mean? Because next move is chapter 5. You know what I mean? So this thing is going to keep moving, and you don't want to still be in chapter 1, and if you can help it. So that's the marker right there. As we progress throughout these sessions, you want to be trying to keep up to the best of your ability. Once again, if you're in chapter 3, chapter 4, and we're in chapter 5, that's not that big a deal because you can, you're around there, but you don't want to still be chapter 1, chapter 2 when we're about to go on to a third test. So that's how you want to gauge yourself. Next class period, I will open the floor for questions. The floor will be wide open for you to ask whatever you want to ask. If questions are generated, hold on. Today is, today's Monday. I'll open the floor for questions. If you don't have any questions, I'll go ahead to chapter 5. Next class period, once again, I'll open up the floor because, maybe questions were generated over the weekend, in which, it'll be your opportunity to ask whatever you want to ask before I do anything else. So the next 2 class periods will be, your opportunity to ask whatever you want to ask first before we go and do anything else. Questions on anything I've said? Any questions? Make sure we're good. Because like I said, that closes out chapter 4. And we're looking to move on from that, especially since we don't have a proctored test. All right. So if you guys are good, I am good. Get in there, see if you have any questions, and I'm here to answer them. Also, if you don't want to wait till class and you want to shoot me an email, feel free to do that as well. Other than that, you guys have a great one. I know I'm staying on for one of your classmates because she had a question about logging on. But outside of that, you guys have a good one. Be safe, and I'll see you next class. All right.
Thank you.
Thank you.
Thank you.
Thank you. Have a good one. Y'all take care. All right. Let me stop this recording, and then I'll see what you got going on.